All right, you can hear me in the back? Very good. All right. Because I've been around for so long in this business, I get to do my own introduction, which that'll be 30 minutes, and then the rest we'll talk about the subject matter. Just kidding. So first, I'm Mike Kapps. I'm a region manager for Climate Master, part of the Climate Control Group. Today we're going to talk about specifications that make sense in the geothermal industry. For the record, I'm not an engineer. I just started doing geothermal loops. This is dating me, 1983. I've been very fortunate to do it for a few different manufacturers all over the US and 40 some odd countries outside. What I really want to teach you today is some things that I learned. One little caveat as well. I owned a loop business called Loop Master for 20 years and ran that until 2011. We did residential loops and commercial loops all across this country. The biggest takeaway today is you're in a place with a lot of really good peers. Thank you, Lisa, for your presentation previously. If you weren't in here, there's some other engineers as well involved. Talk to somebody. This is really, you're going to hear me talk a lot about communication, because to me, I've just met a lot of really smart people in this business in 40 years. I use that to talk to the next person, help them get smarter along with myself. It's very beneficial. It's about communication. So objectives of this thing is specifications. I mean, if you went on any of the tours yesterday, some of it was eye-opening to me, because I've done geothermal loops all over the Midwest where I live, all the way west, overseas. What they do here in New York is even much different, because there's a lot of funky stuff underground here. You don't run into subways in southern Indiana like you do here or anything like that. What I like to talk about is what makes sense with specifications. You, as people that are getting interested in this, what they're going to do, if you're designing a system for your customer, working with your architect, your manufacturer's rep on the equipment, things that make sense, things that should be included in there, okay? You got to protect yourself, you got to protect your ownership, and you want to make sure the design is correct, okay? I'm going to use the term meaningful specifications. To me, that is, you need to be inclusive. What needs to be in there? There's a lot of really good examples. I mean, when I started in the commercial loop business back in the probably mid-90s, when we started doing that, there weren't a lot of specifications. There weren't anything. We were winging it. We learned from us the mistakes that we made as a loop contractor. Lisa talked about referencing flowing or flushing lineal foot a second and all that. We learned a lot from that. We did everything that was supposed to be done. I still got sued. It didn't really matter. You work your way out of it with the facts. It just happens, you know? You find that I just say it kind of how it is, because I'm not a good liar. It's better just to say it and work through it. Those are the lessons we learn as contractors that you learn from this, and what IGSHP is doing for this new training will be the step that a lot of people can help better educate themselves into your market for geothermal. Risk management, there's a lot of good things in there. I will say, this is not rocket science, it's physics, it's the earth. You don't really change either thing. You can get the best benefit on many of those things by designing the project, putting the right kind of specs so that the people that are designing it, bidding this kind of work, understand what your key goals are and what you're trying to get done. Nobody wants a bad job. And I might tell you some more stories or other things, but there's still way more jobs that are working properly, big jobs, small jobs, everything else. I've been involved in this for a long time, so I've been like, where if we sold 3 heat pumps in a week, we were thrilled. Now it's thousands of heat pumps a year and all these kind of things. And the technology, the advancement of equipment, everything has really grown with it. The knowledge level of the industry has grown with it. Organizations like NY-GEO, IGSHP, and other things, 500 people coming? That's pretty good. You know, some amount of those are vendors, like, you know, manufacturers like myself. People are interested. I look out in this room and I think, y'all probably got something better to do than listening to me, but thanks for coming. We'll talk about high-cost adders, which are things that are added in sometimes, and there will be people in this room that will disagree with what I say, and that's okay, because there's not always one specific answer for what I might mention from my history with what they do here versus what they do in California or somewhere else. Just listen, learn, reach out to your peers. Don't be scared of this stuff. There's so many good opportunities in this industry now. Take advantage of it. In 2011, when we shut Loopmaster down, I thought, it's okay, I don't really have to talk too much about geothermal anymore. No, that was 13 years ago. I'm still talking about it all the time, and it's growing now. With the changes of refrigerant, what's really happened in the industry, this is such a great opportunity. Again, I'm lucky to have the knowledge that I have and to share it with you all, so I appreciate that. And we'll again talk a little bit, following up on what Lisa spoke about the previous one, the education and resources that are available to you. So, to me, I said it, communication is critical. If you don't know it, if your contractors don't know it, do an RFQ, ask the question, don't make any assumptions. The most educated people are the ones that are going to do the job correctly, the people that have the right information. If there's a doubt, ask the question, get clarification. That's what I did in my business. As I mentioned, I'm not an engineer, but I used to sit side by side with engineers in the 80s and 90s talking about geothermal. What do they need to do? The customer was demanding it. Where I come from in the Midwest, schools were a huge market for us. But a lot of people didn't understand they understood how to do the building, load profile, select equipment. Geothermal, God, it's pretty easy to do a boiler and a tower, but to do geothermal, what's involved? We helped educate them for that. We kind of sat side by side with them and walked them through that process. I didn't carry arrows and emission insurance, but I didn't need to. I was there to help them get comfortable with what they were doing. And the peers are here. Peers are at this, they're in other places around the country. Use those resources. Biggest thing I found successful was the engineer of record. Who is the person you're going to work with? Who is the focal point that issued the documents or the go-to person? The engineers, it's their arrows and emission insurance. It's their design. You want to make sure it's correct. Any questions, you want to have a go-to person for that. Owners, whether it be a commercial building, a school, whatever it might be, you're learning now by coming here. This technology is applicable for your 3-bedroom ranch home to a big commercial building. Anybody who went on the tours yesterday saw they're doing buildings with 1,200 units in it, hundreds of boreholes next to a flowing river. It's not hard. It's not impossible to do this stuff. I've been fortunate enough to do a lot of loops and be involved in that, and when I had that business in the Midwest, being involved with contractors that did it in the outback in Australia. People would say, it won't work, it's all cooling. Yes, it does. It does work. You design it, it will work. Just do it correctly. Third-party people that are involved, we're hearing more and more about this. Now as you get into more and more applications, you're going to have more bureaucratic involvement, inspectors, code compliance. Here in New York, I think the rule was you couldn't drill past 499 feet. I think they've worked with the state, got that changed to where it's deeper now. Understand those are things you got to consider. When I worked for one of the manufacturers doing performance contracting for the U.S. military, 850-foot boreholes in granite in South Korea. That's just what you had to do. Nobody really stuck pipes down the hole that far. Would the pipe burst? Would it not? How to do it? A lot of that stuff's pretty easily done. It's day in and day out anymore. Site-specific things. What's required? I was trying to tell people when we went to that board, the active drilling job yesterday, I said, just think, it's cool, you're here, but that drill rig's big. Big truck gets it here, put the information in there, the pre-bid requirement to come visit the site is crucial. Number one, it's harder for out-of-state bidders to be able to do that, but if they want and they want to do it correctly, they're going to send somebody there. Just understood it took, that drill rig is in that site, but you had to get the truck there. Our van that took us there had to park a block and a half away because it wasn't easy to get there. Think about the mobilization to get that equipment there, lay down, all these other things, what's involved with that water abatement thing. So identify those things. If you're doing the specifications, ask your peers, ask somebody like myself in this industry how they can help. What you can do to do it. Specifications, man, there's lots of good examples out there. This is just one that, that's my PowerPoint ability to put something together. Oh, cool, I'll make them turn sideways to get everybody's attention. See, it works, right? There's a lot of great information out there. You can talk to your peers, look at stuff that's been done. A lot of these specifications are on the internet now. If not, reach out to somebody. You don't plagiarize it, but use it for the correct information. I've read a lot of specifications in my life, and there's good things that are in there, great things that are in there that you wouldn't think of originally all the time. So pay attention, look for the resources, they are there. General provisions, I'm not going to read this verbatim, but you want to include the right kind of things. It's really about the details. What is it? And I'm focusing on the geothermal aspect of it, not the equipment selections, not how the piping's done in the building or anything like that. It's really about what makes sense for the specification that is clear and detailed enough for the people bidding this work to do it correctly. The designer of these systems is responsible for the information given and ultimately responsible for the end result. They're going to have a representative following this thing through along with the owner's reps and everybody else in compliance with all the correct standards. Here I put in there New York State Mechanical Code. Probably to work here would be very unique compared to some of the places I've worked. You have to think about the labor that's involved, the kind of wages the labor might be involved, if there any compliance, if it's government with Davis-Bacon and all the other things. That stuff needs to be addressed so it's fair and equitable to anybody bidding it. And you want to get multiple bidders because that's the right thing to do for the customer. You want to make it clear and concise that it's not so specific that only one or two people could qualify to bid it. You want qualified people. ICSPA puts on great courses that are going to help qualify more of those people or certify more of those people as well. This looks a little different now. I think they raised it, but scope of work, big definition. What is my scope of work? What's involved? Is it, you're going to hear bore fields, bore holes, manifolds, header pipes, flushing, antifreezes. Detail it, specify it out very much so. What's involved, like as a local municipality that could be involved, or a city regulation? Here's some of those sites I went to. Could be a subway near there. I understand. I've been at this 40-some years. I learned stuff yesterday. I learned stuff today already. Like, cool. I always had a motto since I started in this industry. I'd like to know more when I went to sleep than I did when I woke up. Most of the time I do that. Just depends on how many beers at the end of the day that I remember the next day. I'm in sales, man. It happens. What's going on? I mean, here, I think Zach told us yesterday that the rule originally was if you drilled, you could only drill so close to a subway line. Now those have been amended a little bit. Things like that are being done. That's not an everyday thing that happens to a lot of people. What's underground aquifers. There's a lot of state regulations allotted to this industry that are coming from the water well industry. Pay attention to that stuff. Nobody wants to make the news for having water going everywhere or polluting an underground aquifer. It doesn't happen. Don't be scared of that happening. Anybody that understands how to drill and do these things properly will understand that. That's part of what we'll talk about in conductivity testing as well. And some of this you're going to hear repeated a little bit. The guy coming after me, a brilliant gentleman, Scott Thompson, will talk a little bit about geothermal feasibility as well. So you're going to get, what's nice is what I heard Lisa talk about, what I'm talking about, what Scott and others here are talking about. You're thinking, oh, I heard that already. Well, that's good, because teaching is about hearing things. You don't always have to hear it once. It's about how do you remember it? What is your resource? I was not always the best academic, but I always knew I just need the place to go back and get that information, or who could I get that information from? You've heard me talk about boreholes, pipe identification. These all have definitions and terms. Some people call it borehole, well hole, bore, whatever they want to call it. I will tell you that English is not always English sometimes. I will say something to somebody. The other day I was talking about how you rotate the fan from the side to the end of a horizontal unit. I said rotate. That word to them, it's flip. So I just said, dude, that's when English isn't English, but it's all the same. So again, communication, ask the questions, find out. Obviously great management of what's happening with it, a plan for that. Like when boreholes are all laid out in the system, it's designed that way. Somebody's going to come out, put a little flagger in the ground where the driller's going to drill those holes. There's a proper documentation process for all that so that they don't just kind of go over there and do what they want to do. There's post-drilling, some drawings and as-built drawings and all that. That needs to be a continual process through the thing, and then at the end of the job, All that should be as part of the closeout as-built document, so that if anybody ever needs to go back, it's not common to go back and have to dig stuff up, especially if it's done correctly. People just want to know where it is. They want a comfort feeling of, where is that stuff? Well, it's under my parking lot. I'm not going to go back to it. People always get nervous, but I've fused thousands of fusion joints, put millions of feet of pipe in the ground, put it in right, just give them the drawing, people know where it is. Most of the time it's about digging a utility through there, something like that. Where the boreholes are, what kind of subsurface piping are going to be involved, needs to be very detailed. Without detail on there, people don't know what to do. They don't know how to bid it. They don't know how to properly design to be able to flush the system, how to properly flow to select the pumps. All that's integral in there. Any deviations of any of this stuff needs to be noted. If things happen in the field, there's a process for when they couldn't drill a borehole or they couldn't go here because they found an underground foundation nobody knew about. That's really going to happen in a retrofit or a tear down, rebuild kind of a situation, especially in a dense city, which is becoming more and more of our market these days. Details of the heat exchanger, you're going to see some pictures and some cool little stuff that's around. I imagine some other presentations I have more detail as well, but the borehole, the spacing, you're going to hear about that. I mean, a lot of people, anybody that's in here probably heard geothermal was great. You're here because you think it's a good opportunity for your business and you want to educate yourselves. There are some boreholes and other jobs that maybe didn't perform as they should or as to design. Borehole spacing, sizing, everything else can be determined. It can be done correctly with some key tools. The type of grouting material we'll talk a little bit about. It'll be described in the specs based on typically thermal conductivity testing, which we'll touch on. Excavation and spoils, what you do with that. There's really a whole lot more to that. I mean, some people say it doesn't really matter. You know, if you put them, boreholes are 20 feet apart or 40 feet apart, most of the time that soil has to be dealt with. If you have contaminated soil, it's a whole nother thing. From the drilling to everything else, sometimes there's specific permits involved for the boring or the excavation, what has to be done with sites. I've done work at the U.S. Marine Corps base in Southern California. To drill the thermal conductivity test, we had to abate all the soil and take it away and have it sampled just before we could dump it anywhere, just because they were concerned about contamination. You need to know that kind of information just to keep you as the designer out of trouble, you as your end owner out of trouble, and you just, nobody wants surprises, so try to get the best information you can up front. That excavation and spoils, details about how it goes back in, what sand bedding and all these other little details. Again, drawings and written documentation is critical to this whole process. What other kind of things are done out there? You know, we're hearing about certification, you know, now it's, which I'm really a fan of. I spoke to Lisa, I said, we need a program that helps educate engineers on design. It's exactly where ICSP's going with their program. That's perfect because you got to understand how to do the whole system before you go trying to figure out how to design a ground loop. There's a lot of whole key processes before you ever get to that. I'm glad we're going to there. There's no reason new people can't be involved in this, but you should be educated and have some certifications and knowledge before you just kind of try to jump into this. And as this industry grows, more people are going to want to come into it. We as a base, with our knowledge, whether you got it 6 months, 40 years, 20 years, whatever, share it. Share that information. Don't worry about trying to keep all this work for yourself. There's so much work to do all over this country, all over this world, and this technology. There's plenty for everybody. Help educate everybody. All ships rise with the tide, I like to say. That experience is very important. Proper qualifications, vetted. Not everybody can always have past jobs. Somebody has to have their first job. It's okay, personal references and other things. And then the owner's representative. Many times they'll have an owner's representative, but that's a person picked out of something and has no idea what they're doing. That person should be qualified to say, oh, I mean, I do school jobs. They'd have a school person that's identified as the owner's rep. They would come out and witness a borehole testing. They didn't know what real testing was. There's programs now to qualify some of those people. Have the school do it as a third party or the building's ownership to do it as a third party person. And those are out there. We'll talk more about that. I talked about pre-bid. Luke Master had 20 some odd people. I had guys that would go out and they'd attend all the pre-bid meetings, see the site, typically to get kind of information. You want to figure out how to get your equipment there, what you want to be able to do to price it effectively, whether you could be able to do things. I won't verbatim read you everything that's on there. Geothermal conductivity testing. We heard earlier in the incentive program that I think Con Edison pays up to 50% of a thermal conductivity test. That's new. I'm glad to hear that kind of stuff. Thermal conductivity testing is pretty critical. I won't say it always happens because sometimes people, they don't have the amount of money that it takes to do it in the beginning. Then it's a lot of feasibility and estimations that have to be proven. It's sometimes harder to sell a whole system if you don't have the documentation and the facts in front of you really how to do it. That conductivity test will tell you way more than just the thermal conductivity and diffusivity of that soil. There's a lot of information gathered out of that. It's not uncommon to see lots of drill rigs. Yesterday on that site we saw one drill rig. You'll see dozens of drill rigs. Some of the bigger higher education jobs, Ball State University in the state that I live in was, I don't know, phase 1 was 1,800 boreholes, phase 2 was 1,200. That's a lot of stuff happening at one time. It can be managed. You can get stuff there. If the civil guy says, nope, I don't want you near me, you're going to slow me all down, specify in there, you know, kind of like within your documentation, kind of the time frame of what it ought to be. That ought to be vetted with the bidders. That ought to be vetted with the owners, the engineer. People have to resource that. You have to be able to get the machines and the other stuff there to be able to pull off 5 or 6 drill rigs on a borehole site. It's not uncommon to do. That pre-bid and being able to go there, that's going to let the bidders, qualified bidders, understand how to get there, get their stuff in there, do it effectively. And it's all about the details are, how do you take all the extra unknowns out of it that affect pricing? It's critical. From, if you don't even understand the conductivity, diffusivity of the soil, that's a safety factor. How do you be specific, right-sized, without a ton of extra on there? Extras just cost a lot of money, so the more detail, the more information up front you can do, the better your job's going to be. Materials, you can see it out there in the lobby. There's a lot of good people in this industry now providing a lot of good materials, from U-bands to prepackaged to vaults to all these other things. That's great to see over all these years. I mean, there are more and more people doing that now. In the earlier years, you'd have pipe, you'd get concrete vaults, you'd have them poured in place, you'd drill all the holes. Now you can buy the whole thing done that the engineer specified for the drop. They drop it in the hole on top of the gravel. Now, where was that when I was doing this deal? Maybe I'd still be doing it. Details of a bore field. This is kind of what you're going to be looking like. As to say, this is what some of the prints and drawings that I had for reference from my industry career in it. Detail of what the borehole looks like, what it looks like, how you want your backfill done, what your bore field's going to look like all the way down to the manifold design, reverse return, sizes. Put the detail in there. People understand it, how to bid it, how to do it correctly. Any engineer's going to understand then about how you're going to flush it, what kind of flow you're going to have per circuit. You know, there are specific elements to this on the geothermal loop design, how much flow per circuit, how much flow per circuit for adequate flushing to remove debris and air, and that's being upgraded now. The old standard was 2 lineal foot a second, which honestly didn't always get the debris and stuff out of there. Lisa mentioned earlier, if the debris doesn't get in there, it's just water and air, it's a lot easier to get out than a hard hat or a hammer, because it happens, especially on large diameter pipe. Even more here, sometimes you look at that, these little circles are kind of what the bore field's going to look like. You've consumed that entire piece of property. So when that thing is being installed, other trades might be working. If it's a new construction, you got to be able to work with all that stuff. So again, don't be scared of any of the stuff. It happens every day, all over this country in various places. Higher volumes in some, lesser volumes in the others, but yourselves being here, this is what we as an industry want. We want to educate more people. We want everybody to go think this is an opportunity for me. Between the local and state incentives, now the IRA incentives, which you're going to hear more about, the opportunities are enormous now within this industry. And I didn't even mention the word decarbonization yet, which is such a big word in this industry. As I talked about vaults, engineers now can select and work with vendors based on their design. These things are delivered to the job. They used to be hand-built on site. The beauty of that is all that labor, which is a big factor that most people can't always properly budget and estimate, You think, maybe what's a few extra hours? Well, if you're paying scale wages, $70, $80 an hour, it's a significant dollar. The tools are there. I'm assuming the software that designs these and other things, I personally not bought anything like this or designed anything like this, but having those vendors and that stuff available, it just brings a lot more to the table. It's just like any industry, this one's grown enough now, a lot more vendors are available, a lot more tools are available to help your bids, your specifications better. Conductivity testing, one of my favorite things. I used to do a lot of these personally because I would run in Loop Master, but also was doing export sales for the company. This gives you so much information. You truly understand. They drill a borehole, you put a loop in it, you let it sit for a week or 10 days to let any thermal heat that you put in it during the drilling go away. You apply heat energy over time. You're going to know the conductivity, diffusivity of the soil, helps you determine the true value of that soil, help you determine the grout that's going to be used when you put it back in there. It's a great thing. Sometimes people say, cool, but I don't have $30,000, $50,000 to do one. You can make some assumptions and verify it in the specifications. I would have to say probably most of the engineers would prefer to have one done to be able to design it correctly. It's not always easy to say, you need 300 boreholes. We'll verify that with the first borehole. Then somebody says, well, what if it's 350 boreholes? That's a big difference. Not that it's not impossible, but that is how some jobs work sometimes. You just have to have an open communication with all parties involved. The pipe again, earlier days, 200 foot of borehole, that's what people did. Then it was 300, then it was 400 or 500. It's the stuff we did in South Korea was 850 foot. Part of that was because there was no room. Anybody who's ever been to there or worked there, here's the house, here's the road. The machine crawled off the road, drilled one borehole, crawled back onto the road. You could do it. You had to understand how to size it correctly, how to be able to flush it. When it was a single circuit, you have to understand when you inject water in an antifreeze, it really never mixes. It's just a big slug always moving around. So you had to mix it and inject it in and displace all the water that was in there. If indeed that's going to be the thing, but it's not in a large-scale geothermal application, you have to keep that in mind. That's where talk to the people in the industry, get that kind of information. Those are unknowns. We figured it out while we did it. The testing procedures, everything else, specifications I've read and what's available out there, you talk to your engineers, talk to a peer that's done it with you or will do it with you. There's great procedures for all that, how to pre-borehole insertion testing, after borehole testing, whole thing testing when it's done. There's a little step-by-step to be able to do that correctly. You can backfill that stuff, bury it, and never worry about it. I buried a lot of stuff, and people say, what do you do if you got to get back? I go, you don't worry about it because you do it right, you don't have to go back. Simple as that. You only go back and fix it when somebody else trenches right through it and rips it up, but you're getting paid to go fix that stuff. When we talk about borehole grouts, there's a lot of grouts in this industry now, from just typical bentonite grout to enhanced grout to silica grouts, graphite-based grouts. That's going to be dependent on the conductivity of your soil. That information is going to be given to the bidders. It's going to be used in the design. I always tell people the soil is still the limiting factor. If you have high conductivity, to me it's worth using or looking at the dollars per foot cost to use a high conductivity grout. If you have low conductivity soil, is it worth it to put in high conductivity grout? It's only going to go fast for that first few inches away. Somebody might disagree with me in there, but that was my experience with it. All of those things factor into how much everything costs as well. Grout samples, other things that are tested and done, proper ownership of that. Grouts, as I said, lots of different kinds of grouts. The software that's out there to help you design loop will let you pick the size of the pipe, the grouts, probably more things than I remember now. I haven't run any selections in a long time when we're doing a geothermal loop design. Pretty simple. That's what it looks like on the left. Don't assume it's going to backfill by itself. It doesn't really do that. No state or nobody's going to allow you to leave a borehole open like that. You're going to get the biggest thing you got to make sure you're not doing is cross aquifer contamination or surface water contamination. Can't do it. You want that backfill around there. That's the grout. You want to make sure your process and your specifications denotes the kind of grout you want, the kind of backfill, power grouted from the bottom to the top. That's the way to assure you're filling that annular space around it. Then you're going to get your conductivity, either heat of absorption or heat of rejection for that loop. On the right, you see it's kind of what it looks like when you dig one up. It should look like that. That's in a ditch in Montana somewhere. I took it myself. I thought, oh, cool, that's a good picture. I can use that in a PowerPoint someday in New York. Who would have known that was 20 years ago? Lateral piping or manifolds or supply and return piping, a lot of different terms for that. Be detailed with it, what it looks like. You'll see when they're nicely separated out in a bore field or in a manifold trench back to a vault or to a mechanical room. Sometimes you see them laying all over the top of each other. When owners and people see stuff like that, they think, wait a minute, that's a lot of thermal interference. It doesn't have to be that way. Given the right space, you should displace those from each other, insulate them from each other if you really need to. If you're in a very heating dominant or frost is 4 feet deep in the ground, pay attention to those kind of things as well. Proper GPSing, tracer wires, other kind of stuff should be addressed in there. Flushing and purging. We had great equipment to do that. Now there are people that do that as a third party, which I highly recommend. The loop contractor installing, in my opinion, and this is my opinion, you'll have arguments, other people have their own. They can do a certain amount of it, but most people don't have the equipment to do it at the scale and the volume it really needs to be done with filtration down to low microns to be able to do it. There are companies that specialize in just that kind of flushing. Now, they do loops, they do building ring loops in a building. They're out there now, so it's sometimes worth looking at as a third-party thing, especially when you start involving antifreeze as well. Antifreeze and charging. Some people don't put any antifreeze in it if you don't need it. If you don't need it, you don't need it, great, because it's a lot of money, it's pump factors, other things like that. If you got to do antifreeze, there's choices: propylene glycol-based, ethyl glycol-based, and other kinds of stuff. Methanol in certain areas, but it is toxic and some other things. So pay attention what the state likes. Probably the most common is inhibited propylene glycol. And it's more than just that. You got to detail what it is. You should detail the type of water that's going to be in there. You can't use the water that's coming out of the drill rig's truck that you filled the loop with. It should be blown out. You should have pH neutral water, in my opinion. To me, that's the best way to do it, because you're not going to hurt the pipe, but it's everything it touches in the building, if it's copper, if it's Victolic steel, whatever it might be. Remember, you got a lot of different pieces of pipe coming in there. Final sample should be approved and inspected, all that kind of stuff. High cost adders. This is something they brought into there that said, what is this stuff? What is it, high cost? As I mentioned earlier, safety factors. If people don't know, they're going to try to bid stuff bigger. If they don't know in the initial design, they're going to add boreholes. Now that the IRA is out, and I'm not a professor or professional on everything that the IRA tax credit program has, you don't have to necessarily do 100% of the bore field for that. Now, if you don't have the room, you don't have the money, the IRA can play a big role in that to satisfy the heating requirements with the bore field. Do a hybrid method after that. Not all markets like hybrid methods. Not all markets want to be able to use water, but that's a pretty good opportunity. Investigate that. The software tools will allow you to model those things. Excessive scope. Don't put a lot of stuff on that poor driller guy that's bidding it, because it's typically vertical on a commercial loop. If he doesn't know how to do it, he's got to go, find a third party. Maybe make that a third party thing, because you're just adding cost and hassle to them. Maybe they're not that comfortable with it. It's a good thing to bring in. I was a big fan of, we did our own flushing and stuff, and a lot of people still do that because they've ramped up their ability to do 3 to 5, 6 foot a second to be able to do it properly and filter it, because you don't want to end up in court because they quote say you got mud in your loop, but it's the rust from the Victolic steel from the building that sat there for 2 years before. Inject a good antifreeze into it with a third-party person, and you think, oh, no big deal, we're just pushing the water out. Most people won't necessarily just let you shove thousands of gallons of water out because they don't know what's in that water. You might have to haul that water away. So those are factors. You can't make assumptions like that. Keep that in mind. Earlier days, and I hope to God not much now, this isn't science projects anymore. Those are gone. Don't over-censor it. Don't try to put a bunch of stuff down the borehole. Not saying it's not cool. Those are cool things if you want to do an energy study or whatever, but you're adding costs. If you're slowing the borehole backfill up, the loop going in it for sensors and other things, just understand you're going to add cost and complexity. chances are something happened to that sensor and at some amount of time before you really got all the data you wanted, something will happen. Something will cut it, something will fail. That's just its experience talking as well. A lot of good stuff out there. I mean, there's a lot of good software out there. This is a little bit older slide, but there's good reference information out there. ICSPA's here. ICSPA's probably one of the best resources I feel to be able to do this. You're here. I listened today. I thought I took the CGD test, which was what it was called back in 1984. Had that. It was kind of cool. People were like, oh, he's CGD. I listened. I learned. I've learned a lot more from 84 on, but it just gave me the knowledge to be able to sit with an engineer as a contractor, help them get comfortable with designing their system, which made the owner comfortable, whether it was a school or whoever it was. In my business now, selling equipment to mechanical reps or commercial reps for equipment, I would say, you should be a CGD, go out and get it. This was years ago. I don't do that, I don't design loops. I said, educate yourself, be the resource for information. Everybody in here, for the most part, is a salesperson, whether you're an engineer, a vendor, somebody, you're competing against somebody or something. Find a way to differentiate yourself. A couple of people that worked with me went and got their CG, that was the differentiator. Their owner, the owners of certain projects or engineers wanted them involved. That way they were involved, they were able to sell the equipment that they were representing because they had their CGD. Again, they weren't designing loops, but that got them at the table with the people that were designing it and helped them out. Again, differentiate yourselves. You had to have a little question part of this thing. Now, there are no wrong answers, so that's all good. So I will say, and I don't have one specific answer or anything like that, but I did have to write my own answers down because I didn't want to forget. So does anybody can tell me the definition of a meaningful specification? So remember, there's no wrong answer. Oh, come on, man, I didn't waste my time up here for 20 minutes. Somebody learned something. Yes, sir. Thank you very much. Details, what I've said, very good. Randall, give him 20 bucks. Excuse me? Correct. Very good. Thank you very much. Very good. Anybody else? Yes. There you go, man. I like it. Burke, you got a unique answer. That's why I like you, man. You're a good man, and you sat up front. Randall, give him 50 bucks. Can anybody name 2 specifications that help protect the owners and the contractors on the project? Yes, sir. There you go. Risk management, knowledge, things like that. Anybody else? See, I'm just so good. You guys are all like super smart. You guys are going to ace the test at the end of this thing. I feel very good about that. What information can thermoconductivity test give the bidders? I'm not a very good teacher. Lisa, cool. Correct? Correct. So Lisa said drilling condition, undisturbed formation. That's really critical. Conductivity test is the end result, but all that pre-bid information so people know what they're going to drill in. Sometimes it does change in 20 feet, but the majority is going to be the same within that. And then how many have experience at high-cost adders when they've been reviewed? So I don't know how many, I guess I should ask this, by show of hands, how many people have been involved in designing a ground loop now? Look at that. That's awesome. And I would assume that you've come into finding things at added cost that later, right, wrong, and different, it might have been an owner's request or somebody else. But again, communication, there's no bad questions are ever asked. The only bad question is the one that was never asked. I mean, I find people, even in selling just equipment now for a climate control group, a sales engineer will call me and ask me something, and I go, you need to ask the engineer that. Oh, they're like, I think they're scared to call the engineer and ask the question. I said, that's your risk. If you don't call and ask that, that's silly. I can tell you my answer, but you need to go get the answer from the authority for which designed it. So, any other questions? Anything else? Yes, sir.
Yeah. Should we ever consider value engineering?
Yeah, value engineering can be done. I mean, again, it's worth, if you have a question, it's worth bringing up. Like if you have an idea to be able to value engineer something you think will be brought to it, yes. Just because it's geothermal and it's other things, There's lots of good questions. If you think something might have been designed or the request from somebody, maybe you find to be excessive or you have an idea, ask it. Bring it up as an opportunity. You know, if you think it's a no before asking, you don't know if it's a no. You might have thought of something that somebody else didn't think of. So very good question. Thank you.
Any else with a question?
Look at that. That's just how good I am. Yes, sir.
Please wait for the microphone for the question.
Thank you. You had mentioned pH neutral water. What is your experience with deionized water in the loop?
Great question. I say somebody in here might be able to answer this better. I had some people object to deionized water with the way it mixed with things. I guess it's connection to steel piping or copper and some other things. So I've heard both. So I used to always say like pH neutral water could be deionized water. You will find some of these third-party antifreeze injectors. They'll bring deionized propylene glycol inhibited fluid to the job and push it in. I had just heard different things. Not being a chemical engineer or something, but I've heard there are issues with deionized water in certain applications. Maybe it's just the way it reacts with steel pipe or copper or something like that. So it's worth asking, it's worth doing, but just check out if there's any ramifications. Yes?
You had said, in terms of the pipe fittings, you said socket or butt fusion only. What are the no-go types of connectors for this purpose?
Great question. Socket or butt fusion, you will find that that's a socket looks like PVC pipe in a socket, but it's thermally fused pipe. I didn't really address it because that would be a part of a specification. Good point. Butt fusion is where it's pipe to pipe. Underground, any threaded fitting, a bolted on fitting, like you might have two pieces of polyethylene pipe with a blind with a flange on it and steel. I don't care if the thing's stainless steel and the bolts are stainless steel. That could fail at some point with stress or things like having it. Needs to be thermally fused. A thermally fused joint is stronger than the pipe itself. That's what you learn in any school. That's the only way to really do it. I've put threaded pipe on we just really talked about vertical loops here. There's some cool installations, customer-minded, 1,500 tons of stainless or titanium pond loop in Sydney Harbor. There were flanges on there where the polyethylene met the titanium, but should it ever leak, obviously it's suspended within the piers anyway, but I would never bury any threaded fitting or clamp fitting, barb fitting underground. Good questions. In the back.
We talked a little bit about antifreeze. Should there be anything included about the storage of certain antifreezes and how much extra that you can have? I know for propylene glycol it's non-toxic, so it's not as big of a deal, but there are some projects that use methanol, which is flammable and toxic, so you can't have as much. I think there's also rules that you can't have as much. I don't know.
Those are great points. Propylene glycol is probably the most common. You'll see, it's not uncommon to see pot feeders and other stuff that's in a boiler cooling tower system in a geothermal just because people think it needs to be there. I won't say if it needs to be there or doesn't need to be there. It is a fixed closed loop system, but pipe expands, it contracts, things happen. If you want to put it in there, great. If it's propylene, not a big deal. If it's a non-propylene base, such as methanol, methanol is used a lot in horizontal loops. It's used because it's less expensive, it's light liquid, it's easy to flow. It is toxic, it is flammable. It's flammable in its raw form. Once it's mixed with water, it really dissipates. It evaporates at the same rate of water, I believe. It's what somebody told me, whether it was true or not at the time 30 years ago. I'm not seeing much other than propylene glycol in most systems anymore just because of that. I would say what is the fire code related or fire safety code related to storing anything but a propylene glycol in a mechanical room? Thank you, good question. Anybody else, are you ready for the test? It's only 100 questions, multiple choice. Yes? Oh, wait a second, we'll get the microphone to you so everybody can hear.
Thank you. Question more on the loops testing. And when we talk about testing, it's basically pressure testing, and something what I see most of the time is missed is the flow testing. The
Yeah.
flow testing, because most of the time I saw the flow testing done on site is we pump on one side, we see the liquid on another side, the flow test is pass, it can flow. So
What goes in must come out. If it doesn't come out, that's a bad flow test.
exactly. So what conditions officially come from geothermal industry in terms of flow test? Pressure test is kind of clear. We know.
Pressure test is a hydrostatic test at the pre-installation, post-installation of the borehole. Optimally, I don't see that done. Maybe it should be done more so. An actual flow test that says, okay, I've designed this to flow at 6 gallons a minute, 8 gallons a minute. It should be recorded and done with that. That wouldn't hurt anything. I don't know, Lisa, if you have comments where you require that in any of your jobs or not? No. So it's just more like a flush rate to be done. It's not a bad thing to do. It might be in an adder that costs more money. If you're concerned that maybe you're in a geology for which boulders can collapse over stuff, you worry about it pinching the pipe, that might be something to think about doing.
Exactly. So this is the main point. So basically, when we do the flow test, we're basically trying to check the integrity of the loop in terms of pressure drop, expected pressure drop.
That would be a good detail in there, yes.
Okay.
You'd want to know what that is. That's the only way to really prove that if you got 6 gallons a minute out of it, but you're putting 20 in to get 6 out, you had some pinch point or something like that. It's a great question. Thank you. Made me think. Anybody else? Oh, this will be a good one. Hang on, Trey.
There you go. Is that his question?
So one thing that I've seen over the course of time is poorly written specs, antiquated specs. Are there resources that today's engineers can go to make sure that they're using the latest, the most updated information so that we don't have this ambiguity when it comes time to actually doing the job to go, well, contractors burdened with trying to figure out how to do it correctly because what's written in the specs isn't even made anymore.
It's a great question. I might ask you, Trey, who's a PE, done a lot of loop designs with me around the world, or Lisa, is there a resource to go get good specifications from? Is it ICSPA? There you go, the ICSPA thing. So that was a planted question.
It was a planted question, yes, but
I like it.
But it's important. It really is important. You know, I you know that we've been around doing this a long time, and that's one of the most frustrating things today is seeing outdated information.
Yeah.
And then the contractor is the one who's responsible for figuring it out, and that's not fair.
Right. Somebody mentioned earlier cut and paste. I see it all the time in the mechanical equipment selection time. People will put stuff in there, they'll be like, oh, I can't get your equipment to do that. I go, it's not even relevant. I mean, it's wrong. You know, it's just somebody cut and paste, which everybody's got pressure on their fees. It's easy to cut and paste and do things. Don't put inaccurate information on it because you're going to have to answer as to why it is inaccurate. But thank you very much for that. ICSPA is a great resource for that. Some of the ASHRAE manuals as well. Google the internet, man. There's a lot of good stuff out there too. That stuff's kind of free.
No,
Greg, go ahead.
don't Google the internet. Just go to ixpa.org, please. And we have a general specification guideline
There you go.
that
Perfect.
everybody can use. So it's one of the resources on our website. You can look at the links, you'll find resources, and we have a guide there. And we also have a brand new webinar training course we're going to start rolling out. It's called Selecting the Ground Source Heat Pump Team. And we have some details about specifications and putting together a ground source heat pump design team. That's a new course that we're going to be offering, and so you might want to check that out. You know, people who might benefit from that kind of a class. It's going to be about a 6-hour course webinar, but it's very intuitive, very helpful to people in the industry. We just did a pilot with it with the GSA. We had about 60-some people from the GSA wanted to know that. And worked out so well that helped us build a base for a public training that we're going to offer. So, ICSPA.org.
Yeah, ICSPA.org, IGSHPA.org. Great resource. Greg, give Randall $50. That's how this works. Randall's broke now. He spent all his money. Any other questions, anything else? Yes, right behind you.
Just curious, do you ever define in your specs an allowance for borehole deviation during drilling?
Like vertical deviation from
Yeah.
straight? I've not seen that. I don't know. I mean, I don't even know how you would know if it really deviated unless you drilled into a borehole and saw, oh, there you go. And I have seen that happen.
Yeah.
I don't know, is that Lisa, Trey, have you? It's gonna happen. That- They aren't all like that. Yep. Yeah, it does. Right. Correct. Right. The first time I ever saw that, I was in southern Utah, and they called it Gatorback, and you're on this kind of a, it's not a big slope, but it was a slope, and you had that rock kind of sticking up, which at one point in life, that rock was like that, but it moves, you know? And they're drilling, and you're talking, all of a sudden, black pipes flying up out of the ground and floating there like, ah, crap, man. I said, what happened? He said, I just drilled into that one. I said, man, we're like 60 feet away. But it can happen, because if it hits stuff and it deflects, and if it does, you just got to drill another borehole. There's really no other, in my opinion, not an easy way to account for that. It
Yeah,
happens.
just wondering like how you approach